So we're going to be simplifying each expression by rationalizing, which means get rid of the root in the denominator. So for the first expression, to get rid of the root in the denominator, all we have to do is make sure that when I multiply this fraction by my modified number 1, which means I'm going to pick a numerator and denominator that are exactly the same so that I'm not multiplying this expression by anything other than 1, I need to make sure that the denominator here is a whole number. So in order to get back to a whole number, I can multiply root 8 by itself because the root times itself always gets you back to the whole number. It gets you back to the radicand. The square root of 8 times the square root of 8 is the square root of 64, and the square root of 64 is 8. So if I multiply the denominator by the square root of 8, I have to multiply the numerator by the square root of 8 because, again, root 8 over root 8 is just 1, so I'm not actually modifying the original expression at all. So in order to get rid of a root in the denominator, you always multiply the top and bottom by whatever the denominator is. So when I multiply straight across, root 3 times root 8, I can multiply both of those together because they're both roots, and I get the square root of 24. So this is not completely simplified yet because 24 does have pairs. So if I make a factor tree of 24, that would be 6 times 4. 6 splits is 3 and 2. 4 splits is 2 and 2. So it has a pair of 2's, right? So it has a pair of 2's, which if you multiply that, you get 4, and the square root of 4 is 2. So on the outside, it would have a 2. And what's left in the factor tree is a 3 and a 2. So since a 3 and a 2 is left over, I multiply that back together to get 6. And that's all over 8. One last step to simplify this, I could divide these whole numbers in front by a common factor. I could divide by 2. So my final simplified answer would be root 6 over 4. So this is completely simplified because the denominator is a whole number and 6 does not have any pairs. So for this next one, we're taking the fourth root of 3 over 2x. So what I'm going to do is I'm going to rewrite this as two separate roots. So the fourth root of 3 over the fourth root of 2x. Okay? So our goal is to get rid of the root in the denominator. So we're going to multiply by 1, so we're not going to change the actual value, but I need to multiply the fourth root of 2x by something that gets me back to a whole number. So this one's a little bit trickier than the previous. You can't just multiply it by itself because that will not get you back to a whole number for the fourth root. So I know I have to multiply by the fourth root of something, but it's not going to be 2x. So right now we have a 2, right? So we're thinking, what can I multiply 2 by so that when I take the fourth root of that, I get a whole number, which is why I wrote this chart down here. The fourth root of 1, the fourth root of 16, the fourth root of 81, and the fourth root of 256, all of those give you whole numbers when you take the fourth root of those. So the closest one here would be the 16. So 2 times what would give us 16? Well, that would be 2 times 8. So I know this is going to be an 8. And now for the x's. So far I have one x. And this chart here shows perfect fourth roots. In other words, you're looking for groups of 4. So you need either 4 x's, 8 of them, 12, and so forth in order to get the root to disappear. If I already have 1, how many more would make 4? I would need 3 more. So this needs to be x to the third. So if I multiply the denominator by that root, I have to multiply the numerator by the exact same root. So when I multiply straight across in the numerator, I can multiply both of these together because they're both the exact same index, the fourth root. So I just multiply 3 times 8x to the third, which is 24x to the third. And then the denominator, if I multiply these together, 2 times 8 is 16, and then x times x to the third is x to the fourth. And I know that's going to be a whole number, right? So the numerator, I'm going to keep this as is. And the denominator, the fourth root of 16 is 2. And the fourth root of x to the fourth is just x. So that eliminated the root in the denominator. This is actually completely simplified. And I know because of the following. 24, if I make a factor tree of 24, which we did on the previous side, taking a look at 24, the prime factors are 3 times 2 times 2 times 2. I need groups of 4. There are no groups of 4 that I could take out of the root, so that is completely simplified. And x to the third, if I expand that, there's definitely not a group of 4. So this is completely simplified.